All right, so welcome back everyone. So in the last video we talked a little bit about exploring just a single quantitative variable, and to be honest, it's not on the stats excitement scale. I'd put it at like a 3 or 4. It's not usually the most exciting thing to just have one categorical variable. It's usually more interesting when you're kind of looking at associations between two different variables. And so that's what we're going to jump into next. We're actually going to skip over this part for now, but don't cross it out or anything, so we are coming back to it. And so I'm going to jump from there to page 12. And so almost done with this kind of set of notes. On page 12, we're going to pick up here under exploring two categorical variables. All right, and so what we're going to do for this question is we're going to look at whether infield position is associated with whether or not a player hits more than 10 home runs in that 2010 baseball season. And so infield position, for those of you not familiar with baseball, there's 4 of them. So a player in the infield could either be a first baseman, a second baseman, the shortstop, which is in between the second and third baseman, and a third baseman. So take a second to answer this first question. We answered a little bit of it just now. But for our question of interest here, what are the two categorical variables and how many levels does each variable have? So I'll give you a second to go ahead and pause the video and fill that in. Okay, so the first variable is infield position, and that's going to have 4 levels. So 1, 2, 3, 4. The second variable is whether or not the player hit more than 10 home runs. And that's just going to have 2 levels because either they did or they didn't. So it's either a yes or no type deal. So what we're going to do to look at this data first with numerical summaries is make a contingency table. And so this is the most common form of summarizing data when you have 2 categorical variables. How you would read this is you have 28 players that are first basemen and hit more than 10 home runs. And then you have 15 that are first basemen that didn't hit more than 10 home runs. And then you kind of just go down and read these the same. So you have 10 second basemen that hit more than 10 home runs, 42 that didn't, etc., etc. So take a moment to think about this. And again, you don't really have to write anything if you don't want to, but at least pause the video for a few seconds and just think about whether you think player position and whether or not a player hits 10 or more home runs, if those 2 variables are associated, and then why or why not. All right, so I'm kind of looking at this and seeing that, well, it kind of does look like first baseman and third baseman, a higher proportion of those groups hit more than 10 home runs than the other 2 groups, the second baseman and the shortstops. So I'm going to say yes. It looks like a higher proportion of first baseman and third baseman hit more than 10 home runs than second baseman and shortstop. Again, this is just an informal analysis. We'll talk about how to formally analyze data like this later in the semester. It is also kind of difficult to kind of do these proportions in your head. So with this raw table of counts, what we would do a lot of times is convert it so that the numbers inside the table are what we're going to call row percents or column percents. And so let's talk a little bit about what those are. First, just through an example. And so if we want to answer this question, what percent of first base players have hit more than 10 home runs? How I'm going to answer this is that I see, okay, so what percent of first base players, that means we're only looking at first basemen. So I could get rid of all of the other data. What percent of those hit more than 10 home runs? Well, it's going to be 28 divided by 28 plus 15. And so if you do that, and I'm just going to go ahead and use my phone as a calculator. It's a little glary, but so 28 divided by 43. So it looks like that's going to give you 0.65. So that's the proportion of first base players that hit more than 10 home runs. If you want a percent, you just have to multiply that by 100 to get 65%. This is what we're going to call a row percent because we divided by this row total over here, which was 43. All right, so you can contrast that with this next question, which asks what percent of players who have hit more than 10 home runs are first basemen. The question sounds similar, but now it's asking of the players that hit more than 10 home runs, that's all these guys, what percent are first basemen? So this one's going to be our 28 divided by 30, 40, 69. And so again, if you do that on your phone, 28 divided by 69, that's 0.41 or 41%. And so that's what we're calling a column percent. It's deceptively kind of tricky, the difference between the two. There's just slight difference in the wording, but it does make a big difference. We'll talk a little bit more about when it makes more sense to use row percent and more sense to use a column percent later. But for now, we're going to stop this video here. And in the next video, we will talk about the graphic we would use to look at this type of data, which is a side-by-side bar chart.